Alright guys, back to your test here. This is a review sheet for chapter 8. This is the third page and fourth page I'll be going to. Number 1 here is a simple growth problem where whatever you're going to equal is equal to what you start with. 1 plus the rate is increasing, t is in hours. So we want to know when we have 1,200 bacteria equal to the beginning rate of 150 plus what percent is it increasing? 13%, so that's 0.13 for the t. So we're solving for t here. I'm going to divide 150 over. Okay, so this is going to be 8. And then I have 1.13 to the t. You want to log both sides. Get that t out in front. So right now I have log of 8 equals t times log of 1.13. So let's divide that log 1.13 over. And here we go. T equals, get my graphing calculator here for us. So we got log of 8 divided by log of 1.13. So we got time of 17.0 hours. Okay, so there's your first one. Moving to number 2 with our bank problem. Emily clearly is depositing $15,000 into 2 accounts, one with Bank A, one with Bank B. Now Bank A is compounding continuously, so that means we're going to have how much money we make equals P times E to the RT. Whereas Bank B is compounded quarterly. So it's a growth model, and it's a growth model dealing with compounding interest quarterly. So this is our formula that we're using. Let's go through it. We got our time of 12 years. So there's our T. Here's our rate, and here's our initial investment. All right. So starting with the first one, I will be equal to $15,000 was our original investment. We're increasing at 0.0305, and time is 12 years. So go ahead and do this. This is pretty much a straight punch me in the calculator and record me problem. So I got 15,000 times your E, that would not be E, and that's to the 0.0305 times 12. Gotta make sure that's all in parentheses. So I'm looking at approximately 21,000. Okay, so what we're going to do here is substitute in this into the calculator. But before I do that, I'm going to fix my typo here of this, which should be quarterly, so that should be 4. All right, so this is what I'm going to be typing in my calculator. Okay. So that was interesting. So we have 15,000 times 1 plus 0.0305 divided by 4, all raised to 12 times 4. Okay? So when I hit enter, there you can clearly see this account has $21,599.32. Okay? So, how much more money does Emily withdraw from her savings account from Bank A than from Bank B, assuming that she empties both out? So what I'm going to do is just do a simple subtraction problem here. $21,629.33 minus $21,599.32. So our difference is $30.01. There's our difference. Okay, so we'll pause this and move on. Okay, so this is the elephant problem revisited. We looked at this a couple weeks ago, years ago. Geez. L is 32 centimeters. There's its footprint. Okay, so we're going to say 32 equals 45 minus 25.7 e to the negative 0.09 A. So we're solving for A. We're going to subtract 45 over first. It's going to be negative 13 equals negative 25.7 e to the negative 0.09a. And now we're going to divide this by negative 25.7. So that's gone. Okay, so I have negative 13 divided by a negative 25.7 is a positive. And then this is e to the negative 0.09a. Now, to get rid of e, you need to erase both sides too, or multiply both sides by ln. Mistake. Okay, so what I'm going to actually end up here with is ln of 13 over 25.7 equals negative 0.09a. And whatever that answer is, when we divide it by negative 0.09, that's what we'll get. So ln of 13 divided by 25.7. Okay, so that's negative 0.681541634. I'm going to divide that by negative 0.09. And there is my A value. 7.57268487. To the nearest tenth, we're looking at 7.6 years for the elephant's age. All right, the next part we're going to look at here is going to be non-calcular, so that calculator will be gone. There's your elephant problem. This is the part that you'll be taking on Monday. So you can see it has its own, set of stuff here, directions. You're not supposed to use a calculator without a calculator. So this is the part you can expect to do on Monday. When you see evaluate, you can basically set these all equal to x. These are all common base problems. So we want to get rid of natural log and e and all that stuff by balancing it out. Natural log and e cancels out, so this one's very straightforward. You can, if you want to test it on the calculator, if you have one, you can do that. But that's what you should get. You should know this. This one's 9 to the x equals 1. So basically 9 to the x equals 9 to the 0. So this guy is x equals 0. That one, by definition, you should know. Anything to the 0 power is 1. 1/6 to the x equals 2/16. So I'm going to write this one as 6 to the negative 1. And I'm going to write this guy as 6 cubed. So you can see here we have negative x equals 3. So x is equal to negative 3. And last but not least, no log here. So therefore this is understood to be a base of 10. So I'm looking at 10 to the x equals 10 to the negative third. I'm sorry, not third. It is the negative second. So this is what is 1 over 100, 10 squared on bottom. So we have x equals negative 10. There are your first four. Part 2 is actually more simple than what you think. You have to think to yourself, 5 to the x equals 53. So x has to be between which two whole numbers? Okay, well first off, 5 squared is 25. 5 to the third is 125. 53 lies between these two. So that means our exponent here has to be between 2 and 3. Okay? So if you were going to do this again, say I gave you, let's switch the 5 to a 2. 2 to the what is equal to 53. Well, let's think. 2 squared is 4. 2 cubed is 8. 2 to the 4th is 16. 2 to the 5th is 32. 2 to the 6th is 64. So if you were doing this for him, x would be between 5 and 6. Because 53 is between 32 and 64. That's what you should be ready for on Monday. Hope you guys have a good weekend. Come in ready on Monday to do this part. Okay? We'll see you guys soon. Enjoy your weekend.